Okay, so today we're looking at the 13th video of this booklet, and we're on page 14. On page 14, so we are told that ABCD is a square. So there's 7 properties of a square, but the one that stands out here is that, let me make this a bit bigger, is that the diagonals bisect the vertex angles. Okay, so the diagonal bisect the vertex angle, which means to say A1 is 45, and A2 is 45. Then AEB, which is this E1, is 54 degrees. So that's 45, 54. No? The question says calculate F1. So I can go with sum of triangles. But remember now, in this case here, A1 was not given 45, so we must state it. So A1 is equal to 45, and the reason there is diagonals bisects the vertex angle. So it's diagonal bisect the vertex angle. Okay, which means to say, and you must also remember that the vertex angle is 90 degrees as well. So you can say diagonal bisects the vertex angle in square, and also the vertex angle is 90 degrees in square. Okay, because as you can see, it wasn't also given 90 degrees, so this is vital, you must say that. Okay, so that is now 45 degrees. Now they wanted F1, so I'm going to go with sum of triangles. Okay, so angle F1 is equal to 180 degrees minus 45 degrees minus 54. Okay, gives you 81 degrees. Okay, and the reason there is sum of triangles, and it's triangle AFE. Okay, so let's look at N. Okay, if I had made any mistakes, please let me know on that number. Otherwise, these videos are free. Okay, so in N, we are told that ABCD is a rectangle. So ABCD is a rectangle. So there's 6 properties that comes to mind at that point. Okay, then we are told that DE CF is a rhombus, which means to say all this is equal, and that is 90, and many other, that's 60 and 60, and so on and so on. The question says DEC, the whole angle is 60, so that's actually 30 and 30. Okay, because the diagonals bisect the vertex angle in a rhombus. The question says calculate E1. So as I just indicated, the E1 is going to be 30 degrees. So angle E1 is 30 degrees. Why? Because your diagonal bisect the vertex angle in a rhombus. Okay, diagonal bisect the vertex angle in the rhombus. So that is now 30 degrees. Okay, then they wanted to know F1, which is this angle here. Okay, so that is also 30 degrees. Okay, as you can see, that lengths are equally in a rhombus. So this is always going to be 30 degrees, angles opposite equal sides. But you see, that was not given equal on the diagram, so we must state it. So we're going to say that DE is equal to DF. DE is equal to DF. Why? Because all sides equal in a rhombus. All the sides are equal in a rhombus. Okay, so if you wanted, I could have also said that, which is equal to FC, which is equal to CE. You see, this wasn't needed at this point, so I didn't have to say this part, but okay, since I'm saying all sides are equal, so I'm just saying that there. So then, of course, F1 is now equal to 30 degrees. Why? Because why? It is angles opposite equal sides. Again, if it's not given on the diagram, we must state it. Okay, so there's because 30 degrees. Then they wanted B2. So angle B2 is this angle here. Okay. B2 should be the same as D1 because its alternate angles are equal there. But we need to then prove that that line is parallel there first. In order to do that, which we didn't. B2. So B2, this length and this length is equal. So diagonals bisect each other equally in a rectangle, which that shape is clearly. So then that angle and that angle are the same. Okay. F2 is going to be 30. So this is actually exterior angles was equal to the sum of the two interior opposite angles there. Okay, that's a bit far-fetched, but I'm trying to see if there's an easier way out, which I can't see clearly at this point. So I'm just going to go the long way around. But as I said, there might be an easier way out for this. But I'm not going to waste all the time to think of an easier way out. But as there is clearly a calculation here. So firstly, F2 is going to be 30 degrees. Okay, so let's write that down. F2 is going to be 30 degrees. Why? Because the diagonal bisect the vertex angle in a rhombus. Diagonal bisects the vertex angle in a rhombus, so there it goes 30 degrees. Then we know that this length and that length is also equal. Why? So we're saying FC is equal to FB. Why is FC equal to FB? Because diagonals bisect each other equally. Diagonals bisect each other equally in a rhombus. Diagonals bisect each other equally in a rhombus. So of course that length being equal there. So what you should note at this point is that the exterior angle, let's get a different color, the exterior angle is equal to the sum of the two interior opposite angles. So 60 degrees is equal to that plus that. But we know firstly, before we go into that, that B2 is equal to C1 because of this here. So B2 is equal to C1. Reason, angles opposite equal sides. Angles opposite equal sides there. So twice B2 is equal to 60 degrees. Or we can say B2 plus C1 is equal to 60 degrees, exterior angle of triangle, and it's triangle FBC. Okay, the exterior angle of the triangle, and it's triangle FBC. Okay, so of course both those angles work out to be 30 degrees. Okay, so there's going to be 30 degrees and here's going to be 30 degrees. Again, as you can see, I'm populating this diagram. Okay, and then angle B1, of course, this angle we know that is 90. So we can say that B1, angle B1 is equal to 90 degrees minus 30, which is 60 degrees. And what's my reason there? Your reason is vertex angles 90 degrees in a rectangle. Or you can say the vertex angles are perpendicular. Okay, the lines are perpendicular, or the sides are perpendicular in a rectangle, and so on and so on. Okay, now looking at number 2, I'm just going to change my color here, go black. Okay, in number 2 we said calculate the length of AC. So if you're looking at AC, okay, this time on this video is almost up, just lead it into it. C we see now. Here CE. The length of CE, no, the length of AC, which is our length here. Okay, if CE is 4, so that is 4, that is 4, and that is 4. Okay, which makes that 8. So I'll write it in the next video.